All right, vertex form today. How are we going to get something like this in the standard form of a quadratic looking like this, the vertex form? Now, just a couple things. We are going to have a perfect square. So this does include the skill of completing the square. If you do not know how to do that, you need to watch the prior videos on how to complete a square. Now, the benefit of vertex form is, as you can see, looking at the equation, you know your vertex. Looking at this, I don't know my vertex. Yes, you could find the vertex by finding the AOS, negative b over 2a, yada, yada, yada. That takes a while. So let's find a way that we can make this into the equation we want so it can be quick and move right along. Okay, so here's your steps for completing the square. First and foremost, you need to isolate your variables from your constant term. Now, I can't move anything over because I need to get y isolated so it's in an equation. So my first way of thinking is literally just separating my constant. Now I just put a gap there, but for good reason. I am now going to complete the square of my trinomial. So now I'm just looking at it this way. Well, if you recall from completing the square, the third term is always just half of b squared. So I will be adding 9 to complete this square. Half of negative 6 is negative 3, squared is 9. Now this is where you got to be careful. When we solved by completing the square, whatever we did to one side, we did to the other. But again, y needs to stay isolated, so I can't bring anything over here. But I need to balance this equation back out. I added 9. This right side just got heavier. How do you counteract a positive 9? On the outside, you're going to have to do the opposite, which is a negative 9. So, keep this in mind. However much you manipulate this by, you have to do the opposite on the outside. So now we get some good stuff happening. I get y equals, now that I have my perfect square trinomial, I can write it as x minus 3 quantity squared. Now the two ways to do that quickly, remember the formula that if this is b, that's half of b squared, that's just half of b. Another way that some of you have seen, if it's a perfect square trinomial, square root, take the sign. Whichever one you want to use. Now the back half, I just get minus 2. Oh! And we're done. Notice, it is exactly into vertex form. So if I was diagnosing this and just making sure we identify all parts, my A is 1. My H, careful here, is not negative 3. It's 3, and K is negative 2. That H value throws a lot of people off. The original formula subtracts the H value. So you have to ask yourself, what are you subtracting? I'm subtracting 3. So 3 is my H value. Another way to think about it, a student came up with this a couple years ago. To remember the H and K values, they would just say H is opposite, K is okay. Meaning, whatever you see in the parentheses, the H is the opposite of that, and the K value is okay exactly the way it is. So now that I know my values, I know my vertex is 3, negative 2. Follow-up skill, if you're going to be graphing, what's the AOS? AOS is easy to find here because it is always the x value of the vertex. Remember, the AOS is the vertical line that cuts it right in half so it can actually fold on itself. That's what we call axis of symmetry. That's symmetrical. So, AOS value is not 3. It is not 3. It's x equals 3. AOS is not a number. It is a line. So you need the equation of a line. Okay? One down, killing it. Marker dropped, who cares? Here we go. Notice this one's a little different. I'm still going to take the same approach. I'm going to isolate my variables. Throw that negative 5 out here. But if I truly want to complete the square, hopefully remember the A value has to be positive 1. Currently it is not. Well, I'm going to have to pull out, or technically divide, by what my A value is then. So my next step of the equation is pulling that negative 2 out. Watch what it does to the inside though. Both of these get a negative 2 pulled out, so we're left with x. Oh, just noticed a little flaw. Should be squared. Should be squared. It is squared. And then a minus 6x. I did not do anything to the 5. I only pulled the negative 2 out of the front grouping. And now we can complete the square. Oddly enough, we're going to get the same kind of quantity here. Half of negative 6 squared is positive 9. Pause. This step really throws people off, so take your time here. I added 9 here, but I did more than just that. I added 9 to a quantity that's being multiplied by negative 2. Ooh, tricky. So how much did we just change this side by? Think about it. We added 9, and that's going to get multiplied by negative 2. We just changed that entire side by negative 18. How do you counteract that? You add 18 on the outside. All right, simplified time, and we got our result. Y equals negative 2, quantity of x minus 3 squared plus 13. I now have my vertex form of an equation. Let's go straight to what we need. The vertex is 3, 13. H is opposite, K is okay. My AOS, X equals, extremely important, 3. Quick tutorial on how to get a standard form quadratic into vertex form so we can use that to start looking at vertex, AOS, and begin the graphing process. All right, go get it.